Hello, I'm Anna Mackay. Trigonometric equations, graphically and with technology. Let's do this. So if you're asked to solve cos of x is equal to 0.4, essentially what you're solving then is when does the function equal 0.4, which is the y value. So have a look along the y, when would that be 0.4? Well, 4 grid squares up, 1, 2, 3, 4. This is in your textbook if you want to see it more closely. Essentially, imagine drawing a straight line through 0.4 and working out when does the curve cut through that. So I'm going to attempt to draw that. Up at 0.4 here, there we are, not too bad, using an iPad pencil here. And looking at the intersection of the red line and the black line, and that's essentially the answers that you're after. Where do they intersect? All right, so our first one would be the point of intersection here, that is, you read off the x value. So we would have about 1.2. Next one along would be here, so x is approximately 5.1, and the last one along here is about 7.4 if it was drawn neatly and beautifully. Then, so we have 5.1 or 7.4. So that's essentially what we're solving there. Moving on. Now with technology. So you get out your graphics calculators. Okay, so using a Casio here, you're going into graph. So pick your graph menu, put in your function of cos of x. And now we need to think about what view window we have. Looking at the domain here for x. So in your view window, if you haven't used the trig function, trig view window before, use trig, because that then accommodates for pi and 2 pi and that sort of thing, and it will put your window in a very nice, convenient trig version. So start with that. However, your x and min and max won't be this one. I'd like you to change it to -2 to 12. Think, why might I have done that? So look at your domain. You would definitely do 0 to 10, but it's always nice to have a little bit either side, 1 or 2, so that you can see what's happening right on the edge. So do that. Now, you need to make sure that you are in radians. So if your previous screen didn't give you the exact same numbers that you saw on mine, you need to go into Shift Setup, scroll down until you can find the angle and make sure you pick radians, because radians are when we're dealing with pi. Now go back to your view window and change it if you need to. So here into our function, now we're going to draw that. So hopefully you get something that looks a bit like this. And now we're going to solve. So we need to find the x numbers for when y, the function, is 0.4. So we're going into G-solve here. So we went Shift, and now we're going G-solve, F5. Should bring you this screen here, but we need to arrow across. And we want to work out an x calculation, because we're trying to find x, and it's going to ask us to put in the y. So here we are, we're having to enter 0.4 for our y. And this is what it gives us. So you notice that it's going to start to get a little bit tricky. If you've got your axes numbers on, this number here gets a little bit in the way. So we'll do our best. We've got -1.56. And then if you arrow across to the right, that'd be your right, you'd get the next one. But as you can see, the y-axis is getting in the way. There is a way of adjusting this. Let us accommodate in our view window. If we go back into view window and change it so that we don't have a y-axis and we'll just have it the minute 0, that should accommodate that. So that's a technique that you need to try if you can't read something on your screen. So here's our y-axis, nicely done, and we're going to Shift G solve again for that y value of 0.4. And here we are, we can nicely read off our x number now. Another option is, you may see at the top, if you hit execute, you can show the coordinates. So that's something you could do as well. And we need to list them all off here. Arrowing across right each time, it's clear and easy to read them off now. The third one there, and fourth one there. So it asked us to solve, and so therefore you write down those 4 x values. Good. And last one here, solving this. When does this function equal 4 take x? Essentially what you're doing, because remember we're using technology here, is finding where they meet. So that's a straight line, and the other one is a trig function, and you're finding their intersection points on this domain. So get your graphics calculators out, put them in as two separate functions and graph them. But let's have a look at that view window there. You can't quite see everything that's happening. It's currently to 2 pi as a standard trig there. Notice that we've got no negative x values because we don't need it for this domain. And so yeah, let us go in and adjust that. Having a think back to where that max and min went, look, there's no real right or wrong here. You could try negative 10 to 10, but it didn't look like it was going to be that far away. It's nice to have them even too. And so let's start with negative 5 to 5 and see if that works. Yes, now we can see our intersection points. How many are there? 1, 2, 3. How do we find what they are? We are going into Shift G solve, and you're going to select intersection. And here's our first one. Works it out for us. And so the answers that we actually want are the x values for this. So we would write down, actually I'll do it on the last screen. We've got 1.8 rounding to 2, arrowing across to the next one, 3.28, and our last one there. So our three values are x is equal to 1.82, 3.28, and 5.81. So if you're ever asked to solve where two functions meet, that's the technique that you do. Okay, subscribe if you haven't already, and the next one we will solve these sorts of things algebraically. Thank you.